In the previous lecture, I have taught you about minimization of DFA, and also we have seen an example in the previous lecture in which I explained in detail the step-by-step instructions that you have to follow in order to minimize a DFA. So in this lecture, we have another example where we have to construct a minimum DFA equivalent to the DFA described by this. So here we have a DFA which has 8 states Q0 to Q7, and our task is to design a minimum DFA equivalent to this. That means we have to design a DFA that works exactly like this, but we want to have minimum number of states. So how do we do this? We do this by starting off by writing the equivalences, starting from 0 equivalence. Now how do I write the 0 equivalence? Writing 0 equivalence is very simple. Make two sets in which the first set will contain all the non-final states and the second set will contain all the final states. So here what are my non-final states? Q0, Q1, Q3, Q4, Q5, Q6 and Q7. And what are my final states? I have only one final state here, which is Q2, this one. So I put it in another set. So we are done with 0 equivalence, and the second one is 1 equivalence. Now how do we write the 1 equivalence? For writing the 1 equivalence, you have to use this row of 0 equivalence and check if the states in the same set are 1 equivalent to each other or not. And how do you do it? You take two states and you check where do they go on getting inputs 0 and 1. And if they go to the states contained in the same set, then they are 1 equivalent, otherwise they are not. Let's see how to do this. Let me check Q0 and Q1. Q0 and Q1, on getting input 0, they go to Q1 and Q6. Q1 and Q6 fall in the same set, so it is fine. And on getting input 1, where do they go? They go to Q5 and Q2. Q5 is in this set, but Q2 is in another set, so they cannot be 1 equivalent to each other. Q0 and Q1 cannot be 1 equivalent, so I'll make a separate set for Q1 over here. Now let me check Q3. So Q3 and Q0, this Q3 and Q0, on getting input 0, where do they go? They go to Q1 and Q2. Q1 is in this set and Q2 is in another set. So it is clear from the first step itself that Q0 and Q3 are not 1 equivalent. Now let me check if Q1 and Q3 are 1 equivalent. Q1 and Q3 on getting input 0, they go to Q6 and Q2. Q6 is in this set, Q2 is in another set. Again, Q3 and Q1 cannot be 1 equivalent. So I have to make a separate set for Q3 also. Now let me check Q4. Q4, let me check it with Q0. Q0 and Q4 on getting input 0, they go to Q1 and Q7. Q1 and Q7 fall in the same set, so it is fine. Now on getting input 1, where do they go? Q0 goes to Q5 and Q4 goes to Q5. So they are the same states. So again it is fine, and hence we can say that Q0 and Q4 are 1 equivalent. Q4 are 1 equivalent. And now let me check for Q5. Now Q5 I can check with either Q0 or Q4 because these two are already 1 equivalent to each other. So if it is 1 equivalent to either of them, it will be equivalent with both of them. So let me just check Q4 and Q5. Q4 and Q5 on getting input 0, they go to Q7 and Q2. Q7 is in this set, Q2 is in another set. So they cannot be 1 equivalent. So let me check it with Q1, Q5 and Q1. Q1 on getting input 0 goes to Q6 and Q5 goes to Q2. Q6 and Q2 fall in different sets, so they cannot be 1 equivalent to each other. Now let me check it with Q3. Q3 and Q5. Q3 and Q5 on input 0, they go to Q2, Q2, same states, same set, fine. And on input 1, where do they go? Q6, Q6, again same states, so it is fine. So we can say that Q3 and Q5 are 1 equivalent to each other. So if you check for Q6 and Q7, you can find that Q6 will be 1 equivalent to Q0, Q4, and Q7 will be 1 equivalent with Q1. If you solve this, you can just get this. And remaining one is Q2, so I'll put it in another set, Q2. So This will be what you get if you continue to solve it. Now our next step is the two equivalence. Now how do I write the two equivalence? Writing two equivalence, you have to use this rows of one equivalence for checking. So how do I do? I have to check if the states in the same set are two equivalent to each other. So let me check for Q0 and Q4. Q0 and Q4 on getting input 0, they go to Q1, Q7. Q1 and Q7 fall in the same set, it is fine. And on input 1, where do they go? They go to Q5 and Q5. Same states, so it is fine. So we can say Q0 and Q4 are two equivalent to each other. Q0 and Q4 are two equivalent. Now, let me check for Q6. Is it still two equivalent to Q4 and Q0? So I can just check it with Q4. Q4 and Q6 on input 0, it goes to Q7 and this goes to Q6. Q7 is here but Q6 is here. They are in separate sets. So I cannot put Q6 along with these two anymore. Q6 will form a separate set by itself because it is not two equivalent to Q0 or Q4. Okay, so in the same way, if you check for this, you will find that Q1 and Q7, they are two equivalent to each other, and also Q3 and Q5 also are two equivalent to each other, and Q2 will stay by itself as it is. Okay, so we finish two equivalents, and the next step that we have to do is three equivalents. Three equivalents. And how do you do three equivalents? In order to check for three equivalents, you have to use this row of two equivalents and check if these states in the same set are true equivalent to each other or not. So let me check for Q0 and Q4. Q0 and Q4 on getting input 0, they go to Q1, Q7. Q1 and Q7 are in the same set, it's fine. And on input 1, where do they go? Q5 and Q5. Q5 and Q5 are same states, so Q0 and Q4 are three equivalent to each other. So that is how you do for three equivalents, by checking this row. So in the same way, if you continue, you will find that you will get Q6 over here. Then you will also find that Q1 and Q7 are three equivalent to each other. In the same way, you'll also find that Q3 and Q5 are three equivalent to each other, and also Q2 will come here as it is. And now if you observe carefully, you can see that the row of two equivalents and three equivalents are the same. There is no change. So when you see that two consecutive steps are not having any change, then it is time to stop the procedure. This is your final step. You don't have to continue further. So we can make the new DFA for this. And here, how many states do we have? This is one state, two state, three state, four state, five states. So we have five states. So this will be the new five states that we will be having in the minimized version of our DFA. So here I'll draw the new DFA over here, but before that, let me copy down this original table over here so that we can refer that to fill up the next table. Okay, so here I have my original DFA which was there in the question, and then here I have made this table for our new minimized DFA. So my states here are Q0, Q4, which is here, then Q6, Q1, Q7, Q3, Q5, and Q2. So I have written the states here, and we notice that in an original DFA, Q0 was my initial state. So in this DFA, the state that contains Q0, that is Q0, Q4, will be my initial state or the starting state, and here Q2 was my final state. So here also Q2 is my final state. So let's see, where does this states go on getting input 0 and 1. Q0 and Q4 and getting input 0, where do they go? You can just check this by either checking Q0 or Q4, because both Q0 and Q4 are here. So on getting input 0, where does Q0 go? It goes to Q1. So it will go to Q1. So what is Q1 in my new state? In my new state, Q1 is the state Q1, Q7. So instead of Q1, I will write Q1, Q7. Okay, and on getting input 1, where does it go? It goes to Q5. And instead of Q5, what I have to write is Q3, Q5. The state that contains Q5 is Q3, Q5. Okay, now Q6, where does it go? Q6 on getting input 0, it goes to Q6 itself. Here also Q6 is my Q6 itself, and on getting input 1 it goes to Q4. So instead of Q4, what I have to write? Q0, Q4, the state that contains Q4. So in the same way, if you fill up this table, you can see that Q1, Q7 on getting input 0 it goes to Q6, and on getting input 1 also it goes to Q2, and Q3, Q5 on getting input 0 it goes to Q2, and on getting input 1 it goes to Q6, and Q2 on getting input 0 it goes to Q0, Q4, and on getting input 1 it goes to Q2. So here I have the minimized DFA for this DFA. So in the original one we had 8 states, but here I have only 1, 2, 3, 4, 5 states. And if you check the working, you'll find that both the workings of these DFAs are exactly the same. So this is how you construct the minimum DFA. So I hope this was clear to you. So see you in the next lecture with another example.